Hi, folks. Gene Valentino, and welcome to another episode of Gene Valentino's GrassRoots TruthCast. We do these episodes. We deal with the political world, we deal with the social world. We've expanded into friends and family and nuances of all types, issues from daily walks of life in the grassroots of our environment, our neighborhood, our homes, the village, which is where our constitutional republic started. It was in the halls, in the villages, in the church basements of everyday people from everyday walks of life, creating this monster of a concept we call today a democracy sitting within a constitutional republic. Today, we're going to focus on something a little less political and much more enjoyable to me. A full disclosure up front, I'm an investor in a company called American Gene Technologies out of Rockville, Maryland, and our guest today will be the CEO of that entity, Mr. Jeff Galvin. And we're going to talk about one of the spin-offs that we hope is about to occur with AGT called Adammune. Folks, this is the cure for AIDS, HIV. And we've heard a lot about cures for AIDS going back decades. And there hasn't been, in my opinion, ever a real cure for AIDS that directly affected the triggering mechanisms that causes the virus to survive in the human body in the first place. Until I bumped into this company, AGT, Jeff Galvin, through a mutual friend. Full disclosure again, I'm an investor, but that does not affect my ability to conduct a fair and impartial interview with Mr. Jeff Galvin. Jeff Galvin from AGT, when we return right after this. Hey friends, Gene Valentino. We just landed. Quick plug for the wellness company, www.twc.health. And check out the promo code you need to put in there, Gene for TWC. Again, GENE for the number 4, TWC, super discounts included. This is your arsenal. This is your military arsenal. This is your complete kit for attacking all of the biochemical and virus concerns that are threatening our lives today. www.twc.health. Hi, friends. Welcome back to another episode of Gene Valentino's GrassRoots TruthCast. And my guest today is Mr. Jeff Galvin. Jeff is the CEO and founder of a company out of Rockville, Maryland called AGT, American Gene Technologies. Welcome aboard, Jeff.
Thanks for having me, Gene. Pleasure to be here.
Well, I can go through a litany of your bio that goes back 30 years, but I want you to capsulize it in the context of what we're talking about today. Go for it.
Sure. Okay, so I was originally in the computer industry because as a kid, I was just fascinated by computers, and I ended up teaching at MIT and Harvard, and then going out to Silicon Valley and having a really great career in software and computers. I worked at Apple, which was really interesting to me. I learned a lot about, mission-driven cultures and vision and stuff like that. Well, it worked out so well for me in Silicon Valley, I ended up retiring at age 42. I bought a house in Hawaii, and my whole life was just flying back and forth between Silicon Valley and Hawaii. Nothing to do but lie on the beach. And it sounds great, but after a very short period of time, it gets quite boring. I wanted to get back into stuff. And I thought I would, dabble in investing and probably in software or internet or, apps or computers or whatever. When you have money to invest, you get business plans from everywhere. And I got one from Bethesda, Maryland, out here on the East Coast. And through that, there was a little bit of indirection there. Somebody in a lab there had an idea for a business. But when I came out, he introduced me to his boss, a guy named Roscoe Brady, who showed me viral vectors. And my head just exploded. I realized what I was looking at was the future of medicine. What he was
viral vectors, key term for us today. We'll come back to it. Keep going.
Oh, I'm going to tell you what viral vectors are right now, if you don't mind me digressing for just a second, because, I don't want to leave that out there too long. To me, coming out of software, viral vectors are the diskettes for the human cell. They allow us to bring in genetic code into the cell and reprogram how it operates from the ground up. Okay, so a viral vector is that you can take any virus. You probably know that viruses bring in DNA and they use that DNA to hijack your cells and make them sick. Like, as a matter of fact, HIV, all it does is carry in about, I think, 9 genes or something, and it stalls them in a cell and it hijacks that cell forever. It'll be producing HIV virus until the day it dies. And so what viral vectors are, though, are you can take any virus, crack it open, you can scoop out the viral DNA and throw it away. And what you have is an empty shell that can deliver anything. And instead of putting something that makes you sick in there, we can put something in there that makes you better. We can convert viruses into updates for your body that go down to the root drivers of everything in your body, your DNA, and change it. And we can use that to correct disease. And when I got that explanation, I just was like, kaboom. I was like, well, what can't we cure? If we can get down to everything in your body, if we can literally change your DNA, is there really anything that can't be solved? What I saw was that, we'll replace genes that you're missing and we'll get rid of all of those inherited diseases. We can,
So,
yeah.
yeah, so this is more than just the cure for AIDS. This is a cell engineering and therapy that sends the right message to the cell that says, ignore this virus called AIDS. Am I close?
You're jumping way ahead, but you're bringing up something really important, which is the whole concept of the company of American Gene Technologies is much more than HIV. What it is the idea that we are on the precipice of a software revolution for your body, right? What is the major difference between your computer that operates in zeros and ones and the organic computer, the human cell that operates in ACTG, the nucleotides of your DNA? See, every gene in your body is just a series of those 4 nucleotides, and the order of them determine a specific command in the cell. Gee, what does that sound like? The order of zeros and ones in your computer determines a specific command in the CPU of your computer. So we can start looking at human beings really differently now when we start thinking about how to correct problems in the body. I can look at you and go, you know what you are? 37 trillion organic computers on a network that communicates electrically, chemically, and physically, and they collaborate to make you. And they specialize, right? So you have some cells that are muscle cells and some cells that are stomach cells and some that are eye cells with light-sensitive proteins, and you have nerve cells in your brain. But they all come, every single one of those cells has the instructions for them and their operation, not just how to create that cell, but how they operate for the rest of your life is in your DNA. And now we can change your DNA. So what can we do? We can repair things that are bugs. We can send in new DNA that, oh, you're born without a gene, and so you're not making an enzyme that you need in your stomach, and so you're allergic to something, or you are intolerant of lactose or gluten or something like that. Well, we could install a cell, we can install that gene into the necessary cells and correct that problem, because again, we have the ability to change you even as an adult. We can take these viral vectors and we can use them to bring in new DNA, just the way viruses do, but not bad DNA like viruses bring in. No, good DNA like updates bring in.
And how would that distinguish itself from stem cell research or a stem cell therapy?
So stem cells are actually these plastic cells that are early on in the development of a human being, right? So for instance, there's a lot of different types of stem cells. If you look at the human egg or embryo or sperm, and you say, okay, the embryo is, starts off as just a very small number of cells. And you go, well, how does that turn into a whole human being? Well, the way it turns into a whole human being is those things just replicate. And each one of the cells that replicates could become anything, right? At first, those, 4 cells in a fertilized, the one cell of a fertilized egg, all it has is DNA from mom and dad, all right? and it's going to express the DNA. It's going to mix those things together to make eventually another human being, right? It's remarkable. But in that first step, all it is a undifferentiated cell, but it has the capacity to differentiate into anything. This is the science behind developmental biology. And in fact, one of the things that we are coming to understand is that once you're fully formed as an adult, something like more than 80 to 90% of your DNA is no longer used. Now, my personal theory is, well, that's because it was useful in instructing those cells how to differentiate into you, right? So now your differentiated body, every single cell in your body has approximately the same DNA. Well, then why are they so different? Why does your eye make a light sensitive cell and your stomach puts out acid, right? It's because every single cell is capable of anything. But there is something inside that cell called an endogenous promoter. You can think of it as the manager of the cell. It knows what that cell's responsibility is, and it keeps running the part of the software, the DNA, that's important to that cell's health. And so, again, this is why we come back to that. You're just a giant, entity of these communicating cells. Look, your soul is in there, right? Your soul is in there. Your thoughts are in there, your memories, all these things, right? But there's also all these biological functions that allow you to circulate blood and oxygenate that blood and form new memories in your brain and all this amazing stuff. But it comes down to that DNA, and we can
Okay,
affect it.
now let's talk about the science. We
Yeah.
understand, by the way, that's a great description about the science class. I'm going to take
Thank you.
Science 202, and you're the instructor. I'm taking your class. That's a good intro to explaining how it works. Folks, we're talking with Jeff Galvin, CEO of American Gene Technologies. Its HIV focused division is now opening, called Adammune, or has opened,
hmm
and it is so it's taking the science of what Jeff has just described and is now doing what, Jeff? What does HIV, what has AGT created through its patents, which has addressed HIV?
hmm
And what is it now going to do in terms of its focus within the entity called Adammune?
Okay. So from what I've described already, you can see that, we can now go in and modify DNA, and that's going to change the behavior of cells, right? Okay. And we can come up with clever ideas about how to modify cells in order to correct disease. Now, HIV is a very special disease because what it is that a very weak, slow-moving virus. It's actually part of a class of viruses called lentiviruses. Lenti in Latin means slow. And but it has evolved this incredibly clever thing to allow itself to invade the body and to avoid the immune system fighting it. And what that evasion is that it figured out how to infect what are called CD4 cells. CD4 cells are the conductors of the immune orchestra. Okay. What they do is they detect pathogen, and when they see that pathogen, they instruct the orchestra to create an entire immune response against that pathogen. Works great for a cold, for the flu. Most people can fight off COVID, right? Some people can fight off Ebola without medication. Okay. It's just a matter of, slight differences in our immune systems and in our DNA that sort of put us in a range. But almost everybody can get over a cold or the flu, right?
Yeah.
But almost nobody can fight HIV because HIV comes in, it's got these viral particles, and it meets the CD4 cell. And the CD4 cell tries to do what it's supposed to do, which is to latch onto this thing, digest it, thus killing off that viral particle. And then it uses pieces of that digested viral particle to instruct CD8 cells and B cells to create an immune response that will rid the body of that virus. Now, this works great in the case of a cold, right? So the cold virus comes in, the cold CD4 cell finds it, kills it, tells the cold T cells, hey, we got an invader here, amp up, go look for this thing. And the CD8 cells are like jet fighters, right? The conductor of the immune orchestra, another way I like to refer to it is the general of the immune army. The CD8s are jet fighters. They have X-ray vision. They can actually look at cells and go, wait a minute, that cell has that virus that the general told me to look for. Swoop in and bomb that cell, thus killing off a whole viral factory, right? So they are really the workhorse of the immune system to slow the virus in the body. But then the B cells are also being instructed to make antibodies, which are like the Marines, right? They do the hand-to-hand combat with the virus to slow it down. And normally this works great. But when the HIV virus comes over to the CD4 cell, the CD4 cell thinks it's killing it, but actually it's not. The thing sneaks right inside to the CD4 cell and installs its DNA inside the general. The general is now a soldier in HIV's army. It kills off the general, and the general never calls out the immune system. That is the whole reason that HIV is so intractable. That's why so few people are immune to it, because it has just evolved this incredibly clever way to just absolutely disarm the immune system against itself.
So now let's take AGT. So you've done a great job of explaining how HIV has entered the body.
Yep.
And has been as much of a curse on us as a society as it has been worldwide. And so now we see a lot of other alternatives to cure AIDS. What's the difference with our AGT product?
So right now there is no cure for HIV out there. There have been some people that have achieved what's called a functional cure, which means it's a functional in medicine means equivalent to cure. And the way that they did that was by modifying the immune system. Okay, now they modified the immune system using bone marrow transplants, because there's rare people. Remember, I told you some people can actually fight off HIV. They can only fight off the most common form of HIV, but there's a rare mutation in Northern Europe mostly, where people are born with a receptor that is missing. It's like a genetic defect, but it has a positive consequence because that receptor is the door handle for HIV getting inside the cell. So when they're born without the door handle, they're resistant to HIV infection. And the functional cures that have come so far is they've had people that were HIV positive, where they would actually do a bone marrow transplant, very dangerous, very traumatic, and frequently deadly, a bone marrow transplant. But when they transplanted that immune system from the donor who was immune to HIV into the person who had HIV, they achieved functional cure. The guy or gal could go off their medicine, and the HIV could not turn into AIDS. It would suppress it at levels where they were not contagious and where they couldn't get AIDS, and they didn't need antiretroviral medication every day to suppress the virus. That's what we call a functional cure. Now, there's not enough bone marrow on the planet, and you're not going to give bone marrow transplants to, even 1 million people in the United States, because half of them would die from the bone marrow transplant. That's how traumatic it is. So that's no cure, but it does tell you that if you modify the cell, you can make it impervious to HIV, and that's what we do, okay? So we use our viral vectors to carry in a genetic construct into the CD4 cells that put body armor on the general. So when the HIV viron comes along and tries to invade the general, it can't get in. And when it can't get in, the general can do its normal job. It will kill that viron, digest it, and inform the immune system that the pathogen is there. And then the immune system fights it like any other virus.
Okay, so that would be considered the AGT secret sauce. That is the cure. That is the HIV cure.
Yeah, what we're doing is
go ahead.
We're constructing a functional cure, but we're improving on what we've seen in the past. So bone marrow transplants won't do it, but we have a process where we can just take a 300 milliliter blood draw from somebody that is living with HIV. We can isolate those general cells, the CD4 cells that are HIV specific. We can modify them and put the body armor on. We can amp them up to as much as 1 billion of those cells, put them back in the body, and we get an immune response. We've actually demonstrated that already. Now what we need to do is tune this thing so that one treatment might be a one and done functional cure for life.
Now, these are
Okay.
protected under the existing AGT patents, correct?
Oh, that's right. Yeah, we have patents
Oh,
all around this process, all around the material that goes into the genetic construct, the viral vector, the genetic construct itself. No, there's 18 patents around this thing, both domestically and
where do we
international.
stand? Where do we stand with this? So now you've worked through the CDC and the NIH and all the regulatory arms of government.
Mhm.
You've sought the process of a clinical trial, what I call phase one, step one of the clinical trials.
That's right.
Describe that for the less educated folks who are not aware of the process. Explain phase one, phase two clinical trials.
Sure. So there's three major types of clinical trials: phase one, two, and three. But and the original definition of that, essentially, okay, look it up on the internet for more details. But a phase one was considered a safety study. And if you have a drug that wears off, right? Like let's say you're testing, well, they did this actually. You probably know that Viagra was originally a blood pressure medication, and so the first part of the test is you do a dose escalation study on college students or healthy people to see whether it makes them sick, and you try to find out at what dose do they feel sick, because you know if it's going to wear off, you're not going to kill the person, right? Maybe they get sick, they could even end up in the ICU, but they're probably going to recover, right? So phase one was just a dose escalation, and you never knew whether it would actually work on the condition that you're trying to treat, because you were giving the medicine to healthy people, not people that had blood pressure problems or something else. So Viagra was a little bit of a surprise, because in the phase one, people got a side effect that they decided was desirable, and it became a drug. It failed at its original plan to become a blood pressure medication. Now, blood pressure problems are a side effect of Viagra as opposed to the
My
intent.
wife likes side effects.
So,
Oh, I didn't say it. She just left, so I'm okay.
okay. All right. So that would be a normal phase one. But you see, in gene and cell therapy, we're reprogramming DNA. This is forever. So the FDA doesn't even let you do a normal phase one. What they want you to do is write an investigational new drug document that has theoretical evidence that's strong enough to give them a sense that this is probably safe. Then what they do is in the phase one, you don't get just healthy people. You get people that actually have the condition that you're trying to treat. So phase one is like a combined phase one, phase two in a way, right?
So
You're
from
get some.
AGT's point of view right now, we are through phase one. It's more than just it's more than just evidenced out there. It's semi-proven. You've had a select group of people of patients you've tested on, and the results of that. And now, why are we in phase two? And what happens with at the end of phase two?
So okay, so the just to back it up just a little to explain where we are. So yes, we got FDA approval after submitting this IND. They decided it was theoretically safe enough, and they gave us they said do at least 6 patients.
You said
So
IND. I had to step in. IND
oh,
means
investigational new drug application, IND
okay.
application. Yeah, this is the formal way that you propose to the FDA that you'd like to test something, and then they evaluate it and get back to you. So they evaluated it and got back to us, and they said, yeah, they're willing to take this risk, right? I mean, they're the final adjudicators of whether this is safe enough to try it in human beings. And they decided it was worth a try, because what they're in charge of really is the juice worth the squeeze, right? Is the potential outcome of this valuable enough that it's worth the risk? Because there's no risk-free human trials. You're trying something new, you're putting something new in the body. So this is the phase one. First you got to get over that hump. They said, okay, we think theoretically you're over that hump. So they allowed us to test it in anywhere between 6 and 18 patients. So we tested it in 7 patients. So we got 7 people who were living with HIV as participants, and we drew these leukopaks from them. We processed their blood, and we made up to 1 billion of these HIV specific CD4 positive generals of the immune army, and then that were immune to HIV, and then we put them back into their body. And the first thing that you want to see is safety, because we've just put in a whole bunch of cells that have been modified. And the very first and most important thing in a phase 1 study is it safe? Do you get any serious adverse events? The answer was we got 0 serious adverse events. So you can't do any better than that.
And over what period of time was that, Jeff?
Well, at this point, people have had these cells in their body for up to 3 years. So that's a long, long time. But initially, we just had to show for 6 months. So the clinical trial said, show for 6 months that the cells get in there, don't cause any problems. And then the secondary endpoint is what we call blood markers of efficacy, which is show that they engraft, persist, and are durable. In other words, that they behave in the bloodstream the way that you would theoretically expect them to against HIV. But they're not really seeing HIV because these participants were still on their antiretrovirals. So the cells are sitting in the body, but we got to see for 6 months that yes, they engrafted, they circulated, they were operating normally. We could find them, we could test them. They still attacked HIV. If you showed them HIV, they went after it, but we hadn't tried that in the body yet. But that was a very good phase 1. We got 100% in safety and 100% in blood markers of efficacy. And we even saw some very interesting observations that were that these cells, when we first put them into the body, they immediately started amping themselves up. And then they also signaled over to the CD8. So the generals of the immune army that we put in there seemed to be functioning properly, even though we weren't measuring what this does to the viremia, because these people's viremia was very, very low because they were on suppressive medication, antiretrovirals every day. So that was the first phase
what
1.
you're saying is, what you're saying is after a while, it still was there still was resistance in the body from AIDS without the facilitation of AGT putting anything else in.
You could think of it as that all of these participants had antiretrovirals that were holding down the virus, right? And they take them every day, and it's horrible because, all sorts of side effects. Nausea, diarrhea, fatigue, headaches, depression. These are like common daily side effects of taking antiretrovirals. But long term, they get liver, kidney, heart disease, and cancers. And the average cost of treating one of these patients is $1.7 million in direct healthcare costs in the United States. Less than half of that is the antiretroviral medication.
Wait a minute. So what you're saying is that 1.7 million per patient under today's process
is because
would have been a cost saved by the patient for that care had an AGT type product been in place.
Yeah, if our goal,
and you've
done this
testing,
we could say
you've done this testing over 3 years now, right?
Yeah. Well, here, let me continue with the logic of this.
Yeah, let's go back to the timeline, because I compare it to COVID, and they didn't have to wait 3 years to get to market.
Yeah, but then they had unlimited money. You remember Project Warp Speed, right?
Right.
They were just like handing out cash, and this is a different situation. We've had to fund this internally. We've had a lot of great people like you actually put in their hard-earned money in order to support this project, because they believed that we could get to something of value and get a return for them. And we raised $90 million that way.
And this is over the last 3 years now.
Well, we raised the $90 million since over the last 10 years total, but most of it in the last 5 years.
Okay.
And what it's paid for is not just that phase 1 study and all the R&D that went into, developing this product beforehand and all the patents that protect it, but we did a second study called an analytical treatment interruption study, because we had these participants that still have the cells in their body, right? Now, sure, after the phase 1, the number of cells is declined because the cells aren't being stimulated because they're never seeing virus. And you may not know this, but if you kept all of the immune cells that you make during your childhood and your teen years, by the time you were in college, you'd be double your weight, because you make a lot of immune cells to fight viruses. And then when the virus is vanquished, your body reduces the number of those cells back down again and puts them at a memory level. So if the virus comes back, you can react to it more quickly, right? But if you kept all those immune cells, you make so many of them, they really add up. So
Yeah.
what we expected was we put 1 billion of these cells in there and they're unstimulated, they go down in quantity. But we also know that they still have some in there. So the next test was, if we take them off their antiretrovirals, remember they're on suppressive medication, antiretrovirals, then we laid our cells on top of them. What about if we pull out the antiretrovirals now? Will it have any suppressive quality? Now, the short answer is yes, okay? Because here's what we saw. When we took away the antiretrovirals, in all 6 patients that went off their antiretrovirals, we saw all of the signs of an effective immune response. In other words, these generals were surviving the HIV attack. Because once you take away the antiretrovirals, you know what happens? The viral reservoir produces HIV virons that go into the bloodstream, start attacking CD4 cells, right? And setting up viral factories and expanding, right? And because you're not taking the suppressive medication, there's nothing stopping it. But our cells are in there. And we're wondering, okay, are the CD4s going to decline? Because normally when you take a patient off of their antiretrovirals, CD4s immediately start to decline. And the other thing that happens is that since the CD4s are dying off, the CD4s never get a chance to call out to the Air Force, the CD8s. So the CD8s don't react to the virus going up. So the virus will spike. The CD4s will decline, and the CD8s won't do anything. So what did we get? The immune system did the exact opposite. So when we took them off of antiretrovirals, the CD4s remained stable. That's what you want. You see, the CD4s are being attacked, but they're not being killed off. And
Okay,
then the other thing that you want to see is the CD8s reacting. As the virus goes up, you want to see the CD8s go up. We saw that in 100% of the patients. Now, I don't know if you're keeping track of the 100% here, and this is why I'm so excited. 100% safety, 100% blood markers of efficacy, and then 6 out of 6 patients that went off their antiretrovirals showed an immune reaction against HIV. You know how unusual that is? Very.
Let me, before we break for a commercial, would you, and when we come back, let's now finish up on what's happened in phase 2, distinguishing more specifically phase 2 from phase 1, and then talk about where you are right now, the spin-off to Adamune, and what the future beholds. Folks, we're here with Jeff Galvin, CEO, biotech leader, and visionary for American Gene Technologies, committed to pioneering this revolution of research and investigation into gene and cell therapies. It's really quite an amazing new era in science that really changes the way we look at vaccinations, cures, and yes, we're talking about HIV and AIDS as it's been tested, but the science behind this revolution applies to, oh my words, all of the need for immunization for anything that is considered adversary to the body. Jeff Galvin from American Gene Technologies. More with Jeff right after this.
Throughout history, the spirit of patriotism has prevailed. The battles may have changed, but the values remain the same. Today, in 2024, we find ourselves at a pivotal moment where the call for unity, freedom, and a better future echoes louder than ever. For more than 10 years, Patriot Mobile has been committed to supporting the values that make our nation great. With affordable plans and reliable nationwide coverage, Patriot Mobile is not just a wireless service. It's a call to action for those who believe in the American dream. Because this year is not just any year, it's the most important year since our nation's founding. Choose a wireless carrier that shares your values. choose Patriot Mobile.
Hi, friends, and welcome back to the second half of our episode here with Jeff Galvin. Jeff is with American Gene Technologies, CEO and founder. And in full disclosure, again, I am a shareholder. I bumped into him through a mutual friend and found the science of this cure for infectious diseases, cancers, rare genetic disorders, all of these things that we've dealt with, polio in the early days, and oh boy, the different pneumonias and infectious diseases that have encumbered us through history are in a really scaled up, rapid pace being addressed literally overnight, coming upon us, Jeff, almost as fast as artificial intelligence, AI technology. How much has happened literally in the last few months, my words, not years, that has accelerated our thinking on how we approach a lot of the social behavior and lifestyle changes that are before us. The cell phone, my words, 30 years ago wasn't early 1980s, was the size of a printer in the back of your car. Now it's a handheld device that, oh, by the way, one of the things it does is make a phone call, but everything else known to mankind is on it as well. And I see this acceleration of technologies right in the hands of a guy like you, which is why I invested. And by the way, folks, I invested, but that has no bearing on the factual interview we're going to do today. In fact, we're not talking about any form of solicitation here in this interview. In fact, if you want to get more information, you can contact me through my website, and I'll turn you over to one of the representatives in the company. But this is not the purpose or the intent of today's interview. We're talking about the science, its history, where it came from, and what kind of legacy Jeff Galvin and AGT may be creating. And on that note, Jeff, pick it up, and now let's finish off where you left off and maybe segue into the newer company called Adimune.
Yeah, well, Adimune is quite simply the HIV project. What happened was the HIV project got so much momentum that it made sense to make it a separate company, and that's what we're working towards right now. And I'm telling you something that is publicly known. We have entered into what's called a business combination agreement in an attempt to get Adimune to a public listing. But that aside, we think that thing's sort of ready for prime time. And so that is the company AGT that you mentioned that you invested in has actually is in the process of splitting into two companies. One of them is all HIV and the other one is everything but HIV. So, we think that that's the best way to sort of develop our broad portfolio that goes across not just infectious disease, as you mentioned, but monogenic diseases and even cancers. We want to, maximize this for the public good. Anyway, so Adimune is that project, and what I've told you so far was a successful phase 1 and also an analytic treatment interruption. And the only thing that I didn't mention was that once we had finished that analytic treatment interruption and we had seen an effective immune response in 6 out of 6 patients, one of the things that we realized is that the first exposure to the virus acts like a vaccine. So this is just a consequence of that they were exposed to the virus for a short period of time, then we put them back on antiretrovirals. It actually has the effect of turbocharging their immune system. And if our cells are working, the next time we expose them to the virus, they should do even better. And so I'll keep this short, but essentially we asked those 6 patients, would you be willing to go off their antiretrovirals again? And 4 out of 6 agreed to do that. And in all 4, we got a significant additional suppression in the second ATI. And people can actually go to our adimune.com website and they can go over to the presentation is downloadable online with all the data in it, or they can actually see 3 articles that have been published in peer-reviewed journals about this data.
And how does this impact, Jeff, the results and how friendly it is for it to come to market?
Well, I think what this means is that we just need to get statistical power behind the results that we've shown already. So we got 100% of the patients ended up below 25,000 particles per ml. That's hard for people that aren't scientists or HIV specialists to evaluate, but it's less than half of what you would expect somebody to settle in at what's called a set point. That would be a very low set point, would be 50,000 particles per ml. So we've shown significant suppression in 100% of the people that got two ATIs. Now, what do we need to show? One is we need a much bigger data set, because you can't reach conclusions on 7 patients or 6 patients or 4 patients. But I think that we have sort of a remarkable pattern of the data that we keep on getting these 100%. And it makes you think either we're the luckiest company on earth or something good is going on here. So what we need to do now is do a larger study, basically the same study. And what we want to show is that when we do 24 patients, we get a statistically significant number of them that are suppressed in a reliable way over a longer period of time. And once we show
that
that,
underway now?
that
Is that
that is
underway
our
now?
next study. That's what we are raising money for right now, as a matter of fact. So we expect to start that study this year and finish it in the second half of 2025. And if we have, we get the statistical data that we're looking for, then what we're hoping we can do is define endpoints for what's called a pivotal phase 2. So instead of having to go all the way through a phase 2 and a phase 3, if we show enough data in this statistical study that we're undertaking this year and next, then we can apply to the FDA with that data and see if we can define an endpoint where they would give us potentially a limited license to start selling the product. That would be like an in-market phase 3 almost, or
Yeah,
some people
ideally,
call it
that
phase
would be
4.
sometime in 2025.
Well, the application ideally would be sometime in 2025. Then we'd have to run the pivotal phase 2. So we're assuming they agree to it, and which, is we cannot predict the FDA. But what we can do is we can show them what we think is strong data that we can derive a benefit for patients. And we can ask them, okay, what sort of trial do we need to do now so that you'll let us start bringing that benefit to the patients?
So what's the next phase? You're in the broader vetting of the data against a broader pool of 25 people right now.
Yeah, so what we're doing right now is actually raising the funding for this next clinical trial. Now, in the broad scheme of clinical trials, it's pocket change. We can run the whole trial for under $30 million. You probably know that, in theory, it costs $250 million in most drugs to get to a phase 1 result. We've already gotten to a phase 1 result. We've raised a total of 90 million. And in that, we've made a total of 48 patents across immuno-oncology, monogenic disease, and infectious disease. And we've done this successful phase 1 in HIV and a follow-on analytical treatment interruption study. So we've been very, very efficient, and will continue to be efficient. But that's the goal right now, and we're just starting to work on that. To get that money, we're reaching out to large pharma companies that are in the HIV space to see whether they're intrigued by the data, because the data actually has 2 potential values. One is it could enhance treatments. So imagine if one of these treatment companies had a much better treatment that was less toxic and lasted longer, they could get a bigger share of what is a $35 billion treatment market. So we're starting to get some interest from actual large pharma companies that, this data is intriguing, right? If you can suppress the virus, we can reduce the amount of antiretrovirals or try new next generation ARTs, okay? So this is something where there might be some compatibility, but
Yeah,
they're going to take their time to evaluate it.
this this is what intrigued me from day one. The science or the methodology that created the science behind the approach, which is connected to your patents, doesn't it's not about AIDS and HIV anymore. It's more about a scientific process that
Yeah.
reaches out to all other issues. Now, admittedly, AGT is still in place for other things, but and cancers and other issues. But at least in this autoimmune environment, is it fair enough to say your target is AIDS and HIV right now?
Yeah, it is. Right.
But and correct me if I'm wrong, might it be that the other big pharmas can't be looking at this as if they do look at it as competition, they best take a look at. They better knock on your door, is what they better do, because this, to me, is hopefully something they don't buy from you and shelve it. This, I hope, is something they buy from you to partner with you to
Mhm.
launch a strategy at the social greater good for the world, not
Mhm.
just here in the States. Yes,
Well, I'm
no, am
glad
I
I'm
on
glad you're
base?
bringing I'm glad you're bringing that up. So, okay, let's say that the pharmaceutical industry is not exactly modeled with cures in mind, right? Because the problem with cures are you wipe out a disease and then it's not recurring revenue forever. But, okay, I don't think that they're averse to the idea of cures, provided, especially, they could increase their revenues. Now, let's think about this. The the treatment companies are getting something around $600,000 over 30 years of treating an HIV patient. And the side effects of that medication is leading to another $1 million of expense in the healthcare system. But that's not going to the pharma company, is it? Right? That's going to doctors and hospitals and other drug companies or whatever. Okay, so what if we had a cure for HIV? And let's say that one of the HIV treatment companies were to buy it and bring it out. Well, there's 39 million people out there. It's going to take a long, long time to cure everybody. And the price could actually bring in more money today and for the next 30 years. Now, you tell me a large corporate CEO that's not focused on the next 5 years, right? If you could double your revenue for the next 5 years and you're a corporate CEO, would you take that deal? Yeah, you would, right?
Well, full stop right there,
Yeah,
if I may.
yeah.
Let's assume you're correct.
Hmm.
I'm not as impressed about that, tongue in cheek, as I could be about the savings of cost in the insurance industry
Right.
to continue to pay the exorbitant costs to with a remedy that lacks the efficacy that yours does.
Right.
And all of a sudden insurance prices start hopefully coming down a little bit, and that maybe in another sense care is more available to more people because of the reduction in cost, putting
Yeah.
aside the
Yeah.
savings putting
Well,
aside the
look,
savings you're talking about on the delivery side.
yeah. So I think you're on to something very, very important. And I think that everybody is actually on board with you. I think that the problem, it's not a problem, but the reality of, corporations is that their responsibility is to make money for the shareholders. Right now, when you bought into AGT, you had a very unusual situation because the only way we can make you money is to solve a new problem and make the world a better place. So your investment is going towards making the world a better place, and we're driven to do that. And there is no conflict between making money and making the world a better place. They are completely aligned at our company.
Yeah,
Now,
but not at the expense of bankrupting the insurance age industry, not be able to provide the solution.
right. But you see, we are able to we would have to make a solution, not just that worked. We have to make something that works and can be sold. Right. And that's why one of the big things that we thought about when we were creating this is we knew that the cost of it had to be below the current cost of treating HIV patients. And we looked at that, and it's $1.7 million. And we went, a typical cell therapy is less than $1 million. Okay, $1.7 million, $1 million. Which would you rather pay? Obviously, you'd rather pay the $1 million instead of $1.7 million. And what's the other benefits? Hey, These people don't have to take medicines every day, and they don't have to suffer the side effects of those medicines every day, and they don't
Yeah.
have to hide the fact that they have HIV, because they don't anymore. They're just as, healthy as you and I, right? So that's the beauty of this, is it's a win all the way around. Insurance companies pay less, but the pharma company makes more. They were making 600,000, and it's a annuity over 30 years. What if they made $1 million today? Which is better? What's the net present value of $1 million today versus 600,000 over 30 years? They'd
Yeah.
rather $1 million, right?
That's
So
right.
they win. Now, what about the US government? What do they want? Well, what they want is they want to stop the spread of HIV, because there's 35,000 new infections of HIV every year in the United States.
Where
And
spending is totally out of control.
absolutely, right? Think about this. They don't think of it as just $1.7 million in direct healthcare costs. They also think of it as $1.3 million in lost productivity. So they count each one of those patients
That's right.
as costing American society $3 million. Now multiply that times 35,000 new infections. We're talking about $100 billion problem that is started every single year and lasts for 30 years. Okay.
Okay.
So, yeah. You see why
Jeff,
everybody wins. Public policy, everybody wins together.
that's beautiful. Okay, in the last 5 minutes, let's bring it home. AGT, we talked about where it came from, the focus with Adammune on HIV now. We understand a raise is underway to complete the, what do you call it, the more expanded productivity of
It's just an
efficacy?
expanded statistical study. We're going to repeat
Okay.
what we got because we like the data that we got. We just need to show that it is statistically powered, that we can repeat this in a number of participants that we could present to the FDA as this is reasonable proof that we can do that every time.
Okay, timeline and bring it home. Where are we going in the next 6 weeks, 6 months, 3 years?
Okay, in the next 6 weeks, and let's say 3 months, I'm just going to be fundraising. I can't even talk about that because that's the SEC rules. So I'll leave that at that. It's all about putting that $30 million in the bank account and starting up this next clinical trial. Now, the clinical trial should start sometime in the second half of this year, and we should start seeing an interim readout from the data in the second half of 2025. And at that point, we'll have eyes on whether this is potentially a functional cure. It could be a functional cure. So when we repeat this experiment, we're going to optimize the protocol so that we try to get an even better response in the patients. But even if we just get the same response in the patients, if we get statistical power, we think we have a drug that can vastly improve HIV treatment, and that this is a strategic partnering opportunity and a way to make money for our investors, because there is a priority even at a private company. It is to get a return for our investors. So I see two ways to do that now.
And
Yeah.
how does that exist, or does it coexist with the opportunity of big pharma coming in, any of the bigger players, to becoming your partner at Adammune and or AGT?
So we've reached out to companies in the HIV treatment market. I can't tell you specifics because that would be material non-public information, but I can say, yeah, we've gotten some positive feedback at this point. So there are 4 major companies in the HIV treatment space. It is Gilead is the largest, ViiV is the second largest, and then Merck and J&J are also in there. And I think that there's a good argument for these folks to collaborate with us, and we're going to pursue that because it kind of works for them either way, right? So if this is a improved
Well,
treatment,
I don't consider it competition. I consider it a pretty effective partnering for mutual, generally speaking, shareholder value improves not only for AGT, but for them as well.
exactly, like
And
let's say
puts
you're
them
one of the
into a
smaller
market that they
players.
otherwise were not in.
Yeah, well, sure, the HIV cure would give them all new revenue stream. And also with all those patents, they'd be the only ones able to offer it. And think about it, like there's 1 million people just in the United States that would want to be cured. We're spending 1.7 million on them now, and we could spend only 1 million. And okay, well, what's 1 million times 1 million? It's a lot, right? Okay, so there's a big market out there. And of course, but I don't see them as recognizing the cure market. Like when I talk to large pharma, what they really understand is the treatment market. So one of the things that I think is attracting them is that the data that we've shown already says we could improve your treatments in a way where you're way better than everybody else. Now that is good for any of them, and it's good for them today. So we'll see if any of them sort of grab onto that concept. But we're going to make sure that we stay, in touch with them so that they understand that, hey, when you're in a $35 billion treatment market and you can show that you're clearly the best because you have the longest acting antiretroviral treatments with the lowest toxicities, right? Better than all the competition. Well, that means you get a bigger share of that $35 billion market. And every billion counts, right? So,
Well, 1 million times 1 million. Now you're talking federal budget money, for crying out loud.
yeah, I think that if I'm doing the math right, that's $1 trillion, right?
It's way too much for me to count.
I know. It's like embarrassing to even, mention a figure like that. But look, it's not going to happen overnight. But the point is that, there is interest in that. And it is actually at the bottom line, it saves money. We are stuck with 1.2 million people in the United States. And I don't mean to say stuck like in a negative way, but the reality is more than 1 in 300 people out there on the street has HIV. Is that crazy? You see them every day. That has a societal cost. You would like to believe like, hey, they're not a danger, but they're literally there's still some of them that are infectious. So they're passing the disease and they're creating more expense. It's got to come from somewhere, right? They show up in emergency rooms and they need treatment. And, so what's happening is that, no matter what, as taxpayers, we're out of pocket, billions and billions and billions of dollars every year because we have to care for people and new people that end up contracting this horrible disease. Okay, this might be an economic way to reduce those costs overall for society, reduce the costs to the payers, and reduce the burden of people that are living with HIV, and actually make more money for the pharma companies. But we'll see how quickly everybody picks up on this. But in the meantime, we're going to keep moving forward, and it's not that expensive to go ahead and continue to prove this thing. We'd love to have a pharma partner, and I think there's a good chance of getting it. But with or without a pharma partner, it's a very famous Steve Jobs quote. He said, "They'll know they want it when I show it to them."
Yeah.
I'm telling you, when I show them the functional cure, they'll want it. They'll
Hey,
know
look, whether you get another big farmer in with you or not, the pathway's in place for success, and I know from the shareholders I've spoken to, that's what they're in it for. Hopefully, the big pharmas of the world will realize the good social good you're trying to give not only to the United States but to the world. In the last 5 minutes, Jeff, let's hit your computer, call up Adammune on your website. Let's see if you can dance around. While you're doing that, let's hear from you on some of the. Describe who's on your AGT Adammune team.
Oh, okay. Yeah, actually, let me go ahead and pull up here I'm going to share my screen with you. Is that okay?
Yeah, please do. Go ahead.
And what I want to show you is a presentation. It's going to start on a slide that I'm going to move to a different slide. But this just shows the progress over the last 5 years. It's been tremendous. So we had a collaboration with the National Institutes of Allergies and Infectious Disease, one of the top HIV labs in the world. They validated our IND data, and then we moved in over the last 3 years. Even though this has been COVID over those 3 years, we managed to get through 2 clinical trials and to publish 3 articles on the data. But let me get to the question that you were asking, which is you were wanting to see the team here. So let me get to the team slide. right there. Okay. So internally, we have a great team. Two really seasoned entrepreneurs at the helm here. I've been at this for 15 years here at AGT. So I'm getting my street PhD in molecular biology and genetics. Drew is actually an MD, and he's founded a whole bunch of companies. I'm a serial entrepreneur as well. Marcus Conant has been in HIV for 45 years. He was on the front lines of the AIDS epidemic in San Francisco, one of the first doctors ever to detect that a new virus was going around. Jeff Boyle is our CSO. He's got 20 years experience approving drugs and medical devices with the FDA. And you mentioned Barry Wells. He's our head of business development, and he's reaching out to these pharma companies and to investors and helping to power the company with partnerships and the capital to do the studies. Now, over on this side of the ledger, we have the most amazing key opinion leaders. Tommy Thompson, former Secretary of Health and Human Services under George W. Bush, so secretary, on the cabinet in charge of all healthcare. And he has been with us for about 8 years now, big supporter of it. And he will, once we make a separate company out of Adimune, he has indicated that he will become the chairman of the board of that. So that's exciting to me. And then you might also recognize this guy over here. He was head of the CDC, Bob Redfield, under Donald Trump. So he is also has 40 plus years, really 45 years in HIV, going all the way back to, being in the Walter Reed Hospital, being one of the primary people studying HIV because it was a big deal for the Army, right, and the military. But he also co-founded the Institute of Human Virology, which is one of the top research and treatment institutes on the planet. He's one of 3 people. The other 2 people are Bob Gallo, co-discoverer of HIV, and William Blattner, who's actually on our what's called Data Safety and Monitoring Board. He helps to oversee the clinical trials to make sure they're safe. Now, these names down here are some of the top docs in HIV treatment, and this is just a small sample of the top HIV people in research and medicine and in policy that have gelled around this project. So I'm very excited about the support that we've gotten from people in the know, and I think that bodes well for every aspect of the company in the future.
And going forward in the future, Jeff, do you have the slide there that shows the next few years ahead as you hope to show the future?
I do, as a matter of fact. Here we go. Here it is. Okay,
Let's
so
take
here
the
we
last
are
2
in the
minutes
first
on
half
this
of
one.
2024. Okay, and this is the study that we want to do. This is what we're calling a phase 1B, because we're going to repeat the information that we got in the phase 1, but we're going to do it with, our plan is 24 patients. And we think that that will start to yield statistical data that will validate the data that the effect that we saw in the phase 1. Okay, it'll say that this is statistically exhibited by the data. We think that'll happen in the second half of 2025. And our plan would be to go ahead and try to move into a pivotal phase 2. Now, what that would require is we'd have to show the data to the FDA and see if they're willing to define endpoints. Then we would just cancel that study and we move straight into a phase 2.
So the Gileads of the world might find interest somewhere where your arrow is, first half of 2025 or second half of 2025, based on the progression of good stories. Good results.
I think when we hit this statistical data, it's it's going to be very hard to deny what we've got. I think today they can look at it and go, well, it's a small data set, right? We'll wait. But actually, people that are willing to, look deeply into the data and to see how, sort of reliable the theory has been holding up through, multiple stages of this development, might take a more optimistic view on it and might want to partner earlier, especially since the data that we showed already, whether or not they believe we'll get to functional cure, the data that we showed already could be very useful in giving them a competitive advantage in treatment. So that, I think, you might see some partnering activity happen earlier. I can't speak to that, but if we did, we would be bifurcating the project into something that improves treatment and also still pursuing a functional cure, because we think we make the maximum return for our investors and for our partners by getting all the way there. But I'm going to have to explain to the pharma companies a little bit the economics of a cure, so they understand that this time the cure means making more money, not running out of patients. There's just too many patients out there for them to worry about running out of people that want a cure. So it's a completely different ball game for them, and they can make they can improve their profitability by actually perfecting a cure.
Okay, anything in the other slides to this presentation you want to present before exiting?
Well, I would love to show you one thing right here. This is kind of cool. So when we did these two,
Now, you know I'm not a scientist, right?
Yeah, and I'm going to explain this to you
Okay.
in a way that doesn't require you to be a scientist, just requires you to be a smart guy, as we all know you to be. And I think a lot of the people that watch this are going to understand this really easily, and I'm going to try to explain it in that way. So we did this first analytic treatment interruption, and I want to show you why we were excited. Because normally when you take people that are living with HIV off of their antiretrovirals, the virus explodes. That's that black line. So we saw that. But the CD4s die off. That's the blue line. Do these CD4s look like they're dying off to you?
What's a CD4?
CD4 is the general of the immune army. It is the cell that recognizes the pathogen and is responsible for telling the rest of the immune system to
I
react.
call it antibody.
Well, it's not an antibody. Antibodies are made by B cells. The immune system is very complicated. The general of the immune army is just the sentinel T cell that's on the lookout for the virus.
Okay.
When it spots the virus, it calls out to the Air Force and it goes, "This is what you're on the lookout for. Kill it. Go find it and kill it. Get the airplanes up in the air. Launch, launch, launch." And then it also
Okay, so
tells
the
the B
general
cells.
didn't
Yeah.
change much.
The generals didn't change much, and that's the target of the HIV virus. So that is very exciting. Instead of seeing these things decline, we saw them hold their own. As a matter of fact, in most cases, at the end of the study, the CD4 count is higher than the beginning of the study. So these guys were off of antiretrovirals for 6 months, and it didn't devastate their CD4 cells. All right, so that's exciting. But here's the thing that's even more exciting. So those surviving generals, what did they do? They called out to the aircraft carriers and to the airports, and they said, "Launch, launch, launch. We got pathogens in the area. Find them, kill them." And what did you see? They launched. Look at that. Okay, CD8s went up. This is something that you don't typically see when you take people off their antiretrovirals.
CD8s, just for our folks joining, the CD8 count went up. What is the CD8 count?
So the CD8 count means the number of these cytotoxic T cells that are out there looking for pathogen. You see these greatly expanded. Okay, they were down here at about 500. Look at these guys, ended up over 2,000. That's a huge expansion. What that says is that somebody called the emergency signal. Somebody, picked up the hotline to the Air Force. Okay, and the Air Force went out there and did its job. Okay, now what this means is that all 6 patients looked like, well, even this one here, you see, even though it was a small increase in the CD4s and the CD8s, it was reacting. Okay, all of them showed signs of an effective immune response. You see this one in here? Look at how those CD8s went up. That's what you want to see, CD8s rising. All right, that's not typically what you see when you take somebody off their antiretrovirals. Now,
so the CD8 rising is a good sign that says it's attacking the HIV clandestine operation in the body, and it happens in different ways on each of these 6 different people because there are other mitigating factors in the blood of the the ability for the body to defend itself varies a little bit person to person, and that's why there's differences in the 6 charts.
There's variability in the genetics of the participant, and there's variability in the genetics of the HIV that they have in their body. So you got a lot of moving parts here, but that's what's so exciting about this. We didn't filter for a particular type of HIV. We let anybody could come into this study, and all 6 of them showed signs of an effective immune response.
Well, the trigger to me is that the HIV decline, the black line with the triangle in it.
No. That's a misinterpretation of this. Let me clarify that right away. What happened was the HIV went up, and then we said, okay, we've seen the CD8s go up. We put them back on antiretrovirals because we didn't want the HIV viremia to be really high for a long period of time. So you see the dotted line, the thinner black line, it came back down again because we put them back on antiretrovirals. Okay.
No, I that's what I meant is that
Oh, yeah.
it went down when the application, when they were revaccinated.
When they were put back on antiretrovirals. Antiretrovirals aren't a
okay.
vaccine. They're what's called a chemotherapeutic. They're like cancer medicines, but they're milder. But they are like a toxic mix of chemicals in the bloodstream that prevent HIV from actually integrating or reverse transcribing and infecting new cells. And that's why you want to get rid of that. And that's why we're trying to make an immune response that would make those antiretrovirals unnecessary. Now, what's exciting about when we put them back on antiretrovirals, everybody was able to take their same antiretrovirals and they recovered very quickly from the viremia, and they didn't get mutations in the body that needed them to change their medications. So that was another positive outcome from this study. But the study
you mean unintended consequences?
Well, it's not unintended. That's what we were hoping for. We're hoping that
there were no unintended
this experiment, that there was no unintended consequence, right? Okay. Now, this experiment's not over yet because we went to these 6 patients and we said, this first exposure to the virus is like a vaccine, and then we put you back on antiretrovirals. So we give your cells a little time to rest, just like a vaccination. It's not really a vaccine. Okay, it's the actual virus. So you've been exposed to the virus. If these cells are working the way we expect them to, they'll go into activated effector state. And if we let you, if you'll let us take you off antiretrovirals a second time, these cells should work better the second time. And that would be really good data to say, again, that theoretically this thing's working like what it should do. Well, guess what? 4 of them agreed to go off their antiretrovirals, and 4 for 4, they got a major additional reduction in the viremia. Let's look back at this patient here as a great example, okay? Remember, he zoomed up to 570,000 particles per ml. We put him back on antiretrovirals and brought them back down to well-controlled, okay, which means almost undetectable. And that means that they're ready to come off again. Here's where we started the second analytical treatment interruption. Look what happened. This little blip here, it's on what's called a log scale. This level here is nearly 600,000 particles per ml. This level here is about 80 particles per ml. It's tiny because this is 10 to the first. So this is in, between 1 and 2 is between 10 and 100. Between this is between 100 and 1,000, 1,000 and 10,000, 100,000. This is 1,000,000. Okay, that's what a log scale is. So you see this viremia going up here is going up through, this is 1,000, and you can see it's coming up on 10,000 here. All right, but look at this.
Huge drop.
The first time, the cells were very slow to react. But then this tiny little blip in the number of HIV viruses, viral particles in the bloodstream immediately caused the CD4s and CD8s to go up. But also, as the virus started coming up, look at how fast they exploded. They took off like a rocket. That's what you expect to happen in people that are vaccinated. So you see this little auto-vaccination step that we did seems to have had the effect that we hoped it would have. That instead of the virus going way up to 600,000 particles per ml again, look at this. It starts leveling off at around, it's about 2,000 particles per ml. creeps up to about 5,000 or 6,000, gets up to 10,000. This was probably about 16,000. And then you can see it's starting to come down at the end there. But you see, for 4 months, it stayed at a level that was 40 times lower than the first peak. That's that's an exciting result. This one came down 37x from the first peak. Okay, that's also, and this is interesting too. You see where that line's hovering? It's hovering around, 5,000 particles per ml. Did you know that 5,000 particles per ml, it is common wisdom that person no longer needs to take antiretrovirals to prevent AIDS? That their body, if it can maintain 5,000 particles per ml forever, they can't get AIDS. Now, they still are contagious. So we want to go further, right? We want to find a way to bring that person all the way down to 0. You see these little triangles down here at the number 1 line? If they're down at that, then they're non-contagious also. And we think by optimizing the protocol, we might be able to get this set point much lower, maybe even low enough that they're not contagious. All right.
Interesting.
Yeah. And the
Jeff,
way that
I
we're
hate to
going to
say
do
this.
that,
We're just about out of time, but I want, if you take me off your screen and bring us back to our
sure.
thing, how about your homepage? Do you have you want to talk about how can folks talk to you directly, and give us some commercial on AGT, Adamune, and how to reach you?
Sure. Let me go ahead and share my homepage here and give you a little tour around it real quickly. Thank you for that opportunity. Are you looking at my page now?
We are.
Okay. So here's the front page, and just sort of an introduction to what we do. And I think it gets interesting in a lot of different places here. So in the science, it sort of explains how it works. And I think this is an important one. It shows you the patents, and it also talks about the 3 articles that we have that reveal to the public all the data that we've accrued in this development of this project. And this article right here is really something, because it has over 12,000 reads and downloads, which puts it in the top 2% of all articles in that publication. So This is exciting news that's getting passed around. So I highly recommend everybody read that. But this is the latest article on this analytic treatment interruption data that I just showed you. And anybody can read these. I mean, you have to have sort of a logical mind, but read them or send them to your friends who know HIV, because this is really exciting. And also, this is interesting because we have a pipeline. So we have in phase 1 this HIV cure, but we also have 4 other products behind it that are other potential ways to either improve this cure, make it more effective, make it more potent, or are other angles on HIV. So we've got 5 shots on goal here. So it's not just this one clinical study. We aim to just keep on finding ways to knock back HIV until we can cure it. There is some information on, what we've been doing in the clinic. So this is another explanation of some of the data that you've seen.
I can tell your focus is data, and that's what's always impressed me about AGT and Adamune, is that this is not as passionate as you are about all this, Jeff. It's the fact remains is it's founded. Your excitement is founded in fact. And for that, I commend you. There's a lot of hucksters out there selling their goods that are not founded in fact. Now, like any business, I'm an entrepreneur myself. We trip and fall into the mired mess of bad behavior around us sometimes, especially in the business marketplace. But that doesn't mean that the merits of the solution here, with the patents that back it up, are not credible. Or
Yeah. Well, we
I think
try
it's
to
a
do, we try to do good marketing because we have to make people aware of it, but we try to focus on the data because it is all about the science and it's all about the data. And you can read all the news, in this news section. And we have a special section here, even for investors like you, where you can come in here and you can actually, you can contact our business development folks if you have questions. And we even have a place where you can download our presentation and you can see that there's details about the progress on this that's more from an investor angle.
yeah.
So yeah, that's the site, and I appreciate you letting me give you a tour through it.
Well, thank you for joining us in this hour and a half presentation. It ran longer than I thought, but you know what? I think it's worth it because the social and political consequences of this nation and the security of this nation are not unrelated to the abstracted details of this science
Yeah.
that are proven. If it was hyperbole and unproven, I'd say there was reason to pass over you rather quickly. The opposite's true. Any final thoughts or comments to the public before we say goodbye?
Yeah, I just want to iterate what you just said. You're absolutely right that gene and cell therapy as a category, and a lot of the work that we're doing is along these lines because we do have other assets in immuno-oncology, and other people may want to look at the AmericanGene.com website to see some of the things in the non-HIV area that we're doing. But gene and cell therapy itself has the ability to probably wipe out up to 10,000 diseases ultimately. I personally believe that gene and cell therapy is a new drug development modality where we can do so many powerful things in the body that it will eventually be the end of cancer. We'll send radiation and chemotherapy the way of bloodletting and leeches. That is a dream of mine. And HIV cure can be a stepping stone to that dream because I'm telling you, I'm going to take every penny I make in HIV and I'm going to put it into trying to cure cancer, because I think that there's a really good shot on goal there. And if you look over at our website in AmericanGene.com, you'll see why I'm so excited. But that's the point, is that, this is a potential really exciting future that brings so much value to humankind. And the sky's really the limit. We're just seeing the tip of the iceberg now, and yet there's 30 miracle cures out there. There's a cure for blindness. There's a cure for a crippling disease called spinal muscular atrophy. There's 15 different cures to incurable blood cancers that are out there now because of gene and cell therapy. And they've even recently transplanted a kidney from a pig to a human. Okay, they made an organ without needing an organ donor. Well, the pig, of course, was the donor, but they actually made a transgenic pig using gene therapy to modify the pig, where that pig's liver actually could go into a human being. And that was a success that just happened last week. Imagine a future where there is no waiting for organ transplants, where there is an unlimited number of organs, livers, kidneys, hearts for people that need them. This thing is going to cure everything that kills us eventually. It's not going to happen overnight, but over the next 30 years or so, you're going to see just a deluge of miracle cures. This is really exciting stuff. I so appreciate that you have this broad vision, and also for your support as an investor. I really appreciate that. And I hope to, that we'll continue this conversation, because you really seem to get it. And I really appreciate all the incredible stuff you brought out on this.
Well, Jeff, it's a complicated science because it's new. It's new.
Mhm.
It's not. You heard me use the word antibodies earlier. You already educated me as an investor about some of the nuances of what virology is all about and how we're going to find cures in the future that far outmatch Science 101 from high school days in the late 80s and 70s. Yeah, but it's not that the teachers were bad. They were giving us what they had at the time. And today, the science class today is totally unrelated. Kind of
Yeah.
reminds me of when we were programming our computer in college, and we were using DOS and running through campus with a shoebox loaded of IBM 360 punch cards.
Yep.
I don't think any of the students know what an IBM 360 punch card is today.
I bet a lot of people haven't even heard of that. Yeah.
But that just goes to tell you, folks, how grateful I am to having had Jeff Galvin with us today. Jeff, again, is the CEO and founder of American Gene Technologies, Rockville, Maryland. You can go to American Gene Technologies on the internet, or as he suggested, try Adammune. What's the URL address on Adammune, Jeff?
It's Adammune, ADDIMMUNE.com. And then American Gene is just American with the N and GENE, like your very good first name, .com. We named it after Gene Valentino, American Gene.
I'm going to go boast on that with my wife as she rolls her eyes. Jeff, thank you for joining me today. Folks, Jeff Galvin, CEO and founder, American Gene Technologies and Adammune. And he's had a lot of words today on this, and you can see by his passion and excitement, he's had a lot to say, but their actions speak louder than their words. And I can tell you, I would not have been an investor had I not had the faith and trust in this guy right here, Jeff Galvin, and the blood, sweat, and tears the core founding group has put into this organization going back to its inception. Rockville, Maryland, call me, write me, text me. Our contact information is on genevalentino.com or the website, GrassRootsTruthCast.com. If you can't reach Jeff directly, there's more ways to finding us. If you want to find us, please do so directly, www.genevalentino.com, and I'll push you off in the right direction for anything else you may be interested in. Jeff, thank you again today.
Thank you, Gene.
And thank you, ladies and gentlemen. Thank you very much for a very exciting episode and joining us on another episode of Gene Valentino's GrassRoots TruthCast. See you soon.
Thanks for joining us for Gene Valentino's GrassRoots TruthCast. Be sure to like and subscribe, and God bless America.